Cool. That's made out of technetium. Technetium was the 43rd element, and transition metal. Technetium was the first radioactive element with an atomic weight of 98 atomic mass units. Technetium has 43 protons and 43 electrons with 55 neutrons. Technetium was discovered in 1937 by Emilio Segre and Carlo Perrier with a density of 11.5 grams per centimeters cubed. Technetium has a melting point of 2477 degrees Kelvin, has a boiling point of 4538 degrees Kelvin, and technetium was named after a Greek word, technikos, which means artificial. This element, found in several different types of stars, is extremely rare. Dmitry Mendeleev predicted an element 43 in his periodic table nearly 70 years before technetium was discovered. He thought it would have properties very close to manganese, and even named it Ikamanganese. Scientists in 1846, 1847, 1877, 1896, 1908, and 1925 all published reports that they had discovered Mendeleev's predicted element 43. All of those reports turned out to be different elements. In 1937, Emilio Segre and Carlo Perrier published the results of their experiment in which they isolated technetium from a sample of molybdenum. Astronomers have since detected technetium's spectral signature in a number of stars. Technetium serves a key role in nuclear medicine. This is because technetium produces beta particles without gamma rays. Technetium is the only element that is artificially produced. Technetium is a radioactive metal that looks a lot like platinum. Technetium has the second largest magnetic penetration depth after niobium. Solid metallic technetium is shiny and has a slow rate of oxidation to tarnish in air. In its powdered form, technetium will burn. Technetium has the lowest atomic number of any solely radioactive element. Technetium has no stable isotopes, as all of its isotopes are radioactive. There is only one other element, promethium, in the first 82 to have no stable isotopes. 36 known isotopes of technetium have been created. The most stable of these technetium radioisotopes have half-lives ranging from over 200,000 years to over 4 million years. 29 of the radioisotopes have half-lives of under an hour. Only minuscule amounts of technetium occur in the Earth's crust, and these are found in uranium ores. For every kilogram of uranium, there is a predicted 1 nanogram of technetium. However, large quantities of technetium are produced annually from spent nuclear fuel rods. The long half-life of technetium causes concern for the disposal of this form of nuclear waste. Stay tuned for ruthenium.